Hi everyone! Welcome again to my channel, Math is Fun channel. Again, this channel is a channel or educational channel to help you understand your lessons in mathematics. And this is also intended to those who are doing their online classes out there and also who are answering their modules. So hello everyone! Welcome again to my channel. Please do not forget to subscribe my channel and share this one to your friends, especially those who are struggling in mathematics because this channel will help them improve their performance in mathematics. That is a very nice advocacy to help other people to love mathematics and to realize that math is not a difficult subject, but it is a fun and interesting. Are you ready for our next video discussion? Yes, I can see it in your eyes. So now let's start in our next video discussion, which is estimating square roots. I know you have encountered this one in my previous video discussions, but let's just have or give highlight, yes, emphasis rather about estimating square roots. So are you ready? Yes, you are ready. So now estimating square roots, as you can see, of course, let's have first to go over with the, yes, with the first one, sorry for the inconvenience. Yes, let's try to talk about first about squares and square roots. Or shall I say, or we do include the perfect squares. So to start, let's define what is a square number. Okay, so it is also called a perfect square. As you can see, again, we define square number as a perfect square also, or we call it also as perfect square numbers. And aside from that, it is a number that is the square of a whole number. It can be represented by arranging objects in a square. As you can see as a representation there on the screen, you have it example 1, 4, 9, and 16, which are represented by small circles, correct? So these are, or 1, 4, 9, and 16 are examples of square number. So square numbers, we can also have square numbers or use a multiplication table in order for us to remember about square numbers. So you have it there, the diagonal, the color blue, just look at it. We have it 1, 4, 9, 16, 25, 36, 49, 64, and 81. These are perfect square numbers. Are you familiar with the multiplication table before? So there's also a use of multiplication table which helps us understand, or what I mean, helps us to identify the perfect square numbers. So now let's proceed. Square numbers, let's have an example. This is how we illustrate the square numbers. 1 times 1 is equal to 1. 2 times 2 is equal to 2. 3 times 3 is equal to 9. And 4 times 4 is equal to 16. So these are the numbers that are perfect square numbers. We have 1, 4, 9, and 16. We got it from multiplying a number by itself, just like 1, multiplying by itself twice. So you have it 1 times 1, 2 times 2, 3 times 3, and 4 times 4. So now, in this activity, you're going to calculate the perfect squares up to 15 squared. That's part of your assignment, okay? So I hope you're going to write or list all the perfect square numbers in your notebook so that you will be able to memorize it. Because when you try to list them all and then try to memorize it, it will be easier for you to remember it, okay? So we have it 1 times 1. As you can see, this is how we illustrated the perfect square numbers from 1 to, yes, 15, based on the based on the activity that I asked you to do a while ago. So we have it 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. These are perfect square numbers from 1 to 25. Okay, so identify the following numbers as perfect squares or not. Let's do this activity. What about the first one, 16? Is it a perfect square number? Let's see. Yes, it is a perfect square number because it can be written as 4 times 4. Same with 324. It is a perfect square number since it can be represented or can be written in the form of 18 times 18. And 729 is also a perfect square number since you can write it as 27 times 27 or 27 squared. And the numbers that are not perfect square numbers, we have 15, 146, and 300. So please remember the perfect square numbers because later on, even in radicals, in your grade 9 lessons, you will be able to use these concepts about perfect square numbers to solve and even to simplify radical expressions. So let's continue. Square roots and squares and square roots rather. So when we say square numbers, one property of a perfect square is that it can be represented by a square array. So each small square in the array, as you can see there on its left side, the illustration shown has a side length of 1 centimeter. And aside from that, the large square has a side length of 4 centimeters, as you can see there. So there are 16 small squares which are representing the 16 centimeter or square centimeters rather. So this is how you can also represent a square numbers. Remember the area of the squares? Yes, that is the basic concept on this. So the large square has an area of 4 centimeters times 4 centimeters, and that gives you 16 centimeters. So the number 4 is called the square root of 16. So that's the reason why 4 is the square root of 16. So we write it as 4 is equal to the square root of 16, as you can see on the screen. I will highlight it so that you will have the idea. You can so that you can follow rather. So that's it. So now, next, for a while, a square root number is a number which, when multiplied by itself, results in another number. Example, we have 5. 5 is the square root of 25. Why? Because 5 can be written as 5. What I mean is 5 is the square root of 25 because 25 can be written as 5 times 5. So now we can use the following strategy to find the square root of a large number. So example, we have 4 times 9 is equal to square root of 4 times square root of 9, which gives us 36 or square root of 36. And we all know that square root of 36 is 6. So in the method 2, as you can see, we separated the square root of 4 times square root of 9. And of course, the square root of 4 is 2 and the square root of 9 is 3. Then we can multiply them. That gives us 6. So that's another way on how you find of square roots, especially for large number. You can factor them out. Okay? So now, as I presented, we can factor large perfect squares into smaller perfect squares to simplify. Okay, please take down note of that. You can factor the radicand in a perfect square. So, if the radicand is a perfect square number, but it's a big number, so then you can factor it out in order for you to solve it right away and fast. Okay, so let's have activity number or no number. Let's do this activity. Find the square root of 256. If you memorize it, then you can answer it already. Yeah, right away rather. But in this method, if you did not, if you haven't memorized it, then you can factor 256, the radicand, into square root of 4 times the square root of 64. So you can see 2 times 8, then you got, or you will have 16 as square root of 256. Easy, right? Yeah, I know you can get it right away. Next is we are going now to estimate square roots. When do we estimate square roots? Let's see. Example, square root of 25. That gives us 5 because 25 can be written as 5 times 5. What about 49? Yes, correct. That's 7. What about 27? Oh, that is not a perfect square. So we have to use another method to calculate its square root, or its square root rather. Are you ready? Now, we can estimate square roots if there are not perfect square nor a perfect cube. Okay? So please take down note of that. So now, in estimating square roots, not all numbers are perfect squares. So this gives us the idea that not all numbers are perfect squares. Another thing also in estimating square roots, not every number has an integer for a square root. Take down note of that. Another thing also that we have to remember in estimating square roots, we have to estimate the square roots for numbers between perfect squares. So we use still the concept of perfect square numbers to estimate square roots. That is so great, right? Okay, now let's start. Let's study the steps on how we estimate square roots. So to calculate the square root of a non-perfect square numbers, then we have first to do this first step, or follow this first step rather. Place the values of the adjacent perfect squares on a number line. So we can use the number line. Aside from that, you can interpolate between the points to estimate to the nearest 10. So the word interpolate, you will just estimate it or approximate its value. And of course, it's very hard to analyze the steps. We cannot appreciate it without applying it. So now let's try to apply the steps on how we estimate square roots. Example, square root of 27. What are the perfect squares on each side of 27? So as you can see, 27 can be located between 25 and 36. Right, you're correct. So 27 can be found in a number line between 25 and 36. Let's try to locate 27. What is your guess? Okay. Okay, so 27 can be found there, correct? Obviously, from the number line, we have 25 in here. So 27 is located in the side. So as I have said, 27 is not a perfect square, but it can be found between 25 and 36. So what's next? So we all know that 25 is a square root of, or the square root of 25 rather, is 5. And the square root of 36 is also an integer, which is 6. So now, how do we approximate 27? So we all know that half of numbers from 25 to 36, we can find it there. As you can see, the green arrow. This is the half of the numbers. Sorry, it's not half the here. So the half is located in here. The between number, or number between rather, 5 and 6, or 25 and 36, as you can see. So next, is of course, we can now estimate square root of 27 as this. So since the half is here, so you will just count point something in here from 5. So this is 5.1 and 27 is 5.2, 5.3, 5.4. This is 5.5 to 30, and then this one is 5.75 perhaps. Okay, so meaning to say, the square root of 27 is 5.2. So again, we got it from 5, 5.1, 5.2, since 27 is located in here. So that's it. That's how you approximate square root, or yeah, square root numbers. What I mean, estimating square roots where your roots are, where your radicands are not a perfect square. So I hope you got the process on how you use the number line rather, the number line in approximating or estimating the square roots. This is the method one. In the next video discussion, I will be presenting another method on how you do the estimation of square roots, especially when the roots are not a perfect square. Okay, so I hope you're going to continue to subscribe my channel. Do not forget to share it to your friends out there. So now we can say that we can estimate the square root of 27 is equal to 5.2. So we are no longer use the equal sign, sorry. It must be a approximate sign. Okay, that's it. So let's try to check. If we have 5.2 times 5.2, that gives us 27.04, which is closer to our problem, which is square root of 27. So that means our estimation is correct. Okay? Because 27.04 can be rounded it off to 27 or approximately. That's why we use the term approximate, because we are just trying to estimate the square roots. We are not solving its exact value because it's part of the irrational numbers where it is infinite. Okay, what I mean is this is an infinite number, so you can approximate or extend it until you will be tired of it. Okay, so that's why we use the term or the symbol approximate. So I hope you got something from this. So yes, that ends our discussion in this lesson about square roots and estimating the roots, especially the roots are not a perfect square. So thank you so much for listening. I hope you have learned something in my video discussions. Do not forget that you have to subscribe my channel and share this one to your friends. And aside from that, always remember that math is fun. The essence of mathematics is not to make simple things complicated, but to make complicated things simple. That's the magic of math. Thank you so much. Have a good day.